All right. Well, thank you all for coming. We are the SolidWorks Student Leader Program here, and we work on behalf of Dassault Systems, the people who actually make SolidWorks and run that software. They also do a few other softwares, but those aren't really used here. If you've heard of Abacus, I think that's the name of it. It's a simulation software that's also under Dassault Systems, similar to ANSYS. And yeah, so we are the SolidWorks branch of this. It's actually a larger organization across the US where you have different chapters, like in Florida, in Los Angeles. And so we just are here to help provide free exams and to get you guys trained and get you guys certified in the SolidWorks software. All right, we're letting a few more people walk in. Really quickly for our introduction, my name is Suraj Shah, and I am a second-year mechanical engineering student. I'm a part of ASME Flagship, as well as this org and Engineers Without Borders. Those are my main affiliations. And then my partner there.
I'm Abraham. I'm a third-year mechanical engineering student, and this is basically my only affiliation. So I have no conflict of interest.
Yeah, yeah. He has I have a little bit of conflict of interest with my orgs, but we settle it. We make it work, and I think it works out really well. Like I mentioned earlier, we are here not to provide simple basic CAD training that most orgs provide for their members, but to take it a little bit further, give it more advanced CAD training, and to get you guys certified. So moving forward, I basically just read the slide, summarized it. We're here to help you guys get certified. That's the gist of this. There's no need to really read through all these words, but we'll send them out later if you want to. If you guys haven't already, please join our Slack workspace. It's where we'll send out advanced notification notices and other information. And we'll also send out problems and stuff there, and you can reach us more easily through the Slack than through email. If you send us an email, we'll get back to you in like about a day or two. A Slack is a little bit more of a faster response, at least for me. Yeah, you too? Yeah, for both of us. Go ahead. We'll also, I think in the forms, there's the Slack link. We'll also, you can go through this bottom link. You should type in UCLA SolidWorks slp.slack.com. You'll also be able to join. And we'll have it again at the end. So here's the game plan for today. We just briefly went over introductions really quickly, and we're going to spend most of our focus on the CSWA and how to prepare for this. Do you guys know anything about the CSWA? Have you guys heard of it before, or is this the first time hearing about it? Who's heard about it before? Okay, a couple of you guys. Yeah, so the CSWA, it stands for Certified SolidWorks Associate. It's the first certification SolidWorks offers for mechanical design. There's three tiers. There's CSWA, which is associate level. There's CSWP, which is the professional level. And then there's the CSWE, which is the expert level. These are three tiers of mechanical design that SolidWorks certifies. And the way it works is CSWA basically means that, hey, you know your way around SolidWorks. You can, if you're given a problem, you can figure out a way. You don't need to be taught all the basics. A CSWP basically means, hey, you can hit the ground running. I can give you a complicated part, and you'll be able to model it, and I don't need to worry about you at all. A CSWE, that basically means, hey, you're top of the top. You're the one leading the CAD trainings. You're the one teaching other people how to do this. You're the consultant. You don't actually do much of the CAD yourself at that point because you're more so training other people. And that's how the three tiers work. And so today we're training you guys for the first tier, that CSWA exam. It's on its own, it's not a difficult exam, especially if you know how to attack it. And that's what we're going over today. We're going to teach you guys the tactics and tools and skills you'll need to be able to effectively finish the exam and pass it and get the certification. And as I don't know if I mentioned this, but the reason you should take it, one, is a certification that looks really good on a resume. Two, not everyone that does SolidWorks actually has a certification. I believe out of the millions of people that do SolidWorks, only some in the hundreds of thousands have the certification. So it's a very small percentage, meaning you guys will stand out amongst all other people. And for those employers that know what they're looking for and know they're looking for people with CAD skills, they can look for you guys and they'll see it. All right, before we begin with the actual going over the problems and such, are there any questions up to this point? If at any point during our presentation and during our modeling, if you have questions, just raise your hand and we'll come over and help you out, or just we'll point it to you and you can ask it out loud. This is going to be not very strict in terms of we have problems we want to get through, but our main goal is to help you guys learn, and so questions are a great way to actually get a better understanding of the material.
Okay, so thank you. So I think we've already gone over a little bit of like the overview of what the CSWA is. But yeah, it stands for the SolidWorks Associate in Mechanical Design. It is quite a long exam. You don't need to take 3 hours to actually finish the exam. I personally did it in about 1 hour, 45 minutes. So 3 hours is really if you're just really struggling, if you want to take a break in the middle. And you only need 70% to pass, so you know that's pretty good. And you do need a knowledge of basic features, so everything from sketch tools to extrudes, bosses, fillets, chamfers, finishing features, basic drawing understanding, because you will need to identify drawings and, of course, model parts from drawings. You also need to know some of the basic evaluate features like mass properties, inertia, center of mass, stuff like that for assemblies. But yeah, basically pretty much the things that you would encounter if you're a regular user of SOLIDWORKS. Next slide. So the first section of the CSWA is the drawing, I guess, identification section. And so you might be presented, oh, sorry, that's the next slide. Sorry, this slide. This slide is actually the part modeling. So this is like an example drawing that you might see in industry. The drawings that they give you on the exam are going to be slightly simpler. They're going to usually have a drawing view, and then they have like a gallery, so you can go through it and see different sections. So for example, they might give you the isometric view, so you'll only see like the yellow box, but you won't see anything else, right? And so then if you want to see other parts, then you'll have to scroll through the gallery and you'll be able to see the side view, the top view, the other views. And so that's, it's not necessarily how you'll really see drawings in industry, but it's kind of representative of that. Next slide. And so this is more like what you would see on the exam. The dimensions are nice and big, and it's easy to read, which might not be the case if you're working with handwritten drawings in a real job. But for example, like we have all these dimensions here, and then you have this P here. So P indicates a view that's normal. So you're looking down on this, right? And so then if you go down to where P is, which is that in the corner, so then you can see that P, that's what you would see if you look down from this top view, or like from this angled view. And then J as well in the other sections as well. So you have to kind of have a really good visualization. You have to be able to see things in 3D and move them around in your head, because they're not necessarily going to provide you with just an isometric view or the view that you think that you will need. So you need to be able to construct that. Also, you need to be also be able to figure out which feature you'll want to make first. So for example, you could always just start with the bottom, this section right here, and you can add everything on top of it. That's not necessarily the most efficient way to create a part, right? If you want to create the part in the least amount of features possible, you want to save time on the exam, then you might want to consider which feature you want to make first. So yeah, there's a lot of considerations that goes into interpreting these drawings. We're going to be covering these soon after we go through this drawing identification section. But yeah, it really just comes out in practice.
I think, yeah, going off on that, the practice of like being able to visualize it and see the part and rotate it is just practice. The more you work with 3D models, the better you'll have of an understanding of what orientation is this, because this is not an easy thing to visualize, especially with the different colors and the angles, because it's not a perpendicular face. Like these are 3 different faces at different angles. And understanding that is just a matter of practicing and realizing how to visualize that model in your head.
So this is, I guess, this is the first section of the exam, an example question you might see. I call this a drawing identification section. It's quite simple. It's always multiple choice. So, I mean, you have a pretty good chance of getting it right. But yeah, this is a pretty simple question. How about we maybe take a few minutes, maybe 1 minute or so, and then try to figure out which choice you should select. Usually these questions are pretty straightforward because you can kind of ascertain what the drawing view is just by reading it. But yeah, we'll take 60 seconds and then see what the consensus is.
One way I'd recommend is process of elimination. If you know what some of them are, and you know it's definitely not what the image is showing, then you can just cross it off your head and then narrow it down to less options. Also, we are recording this, or trying to record it at least, to post up afterwards, and the only way that it will record audio is if you hear the mic in the speaker system. So if at any point you don't hear one of us through the speaker system, do let us know so we can make sure that we're talking, that can be heard in the recording.
Okay, I think it's been about a minute. What do you guys think? A, B, C, or D? What do you think? B? Okay. Why do you think B? Okay. No, that's good. That's possible elimination. So that is correct. So an isometric view is, of course, the most common view you should see of a part. You can see 3 faces at once. So that's A, right? You can see all of it, but that's definitely not B. Projected, that's kind of like PP that we saw, where you're kind of looking at it from an angle, right? And so that's definitely not B, because you're not seeing the whole face, right? You're not seeing the whole part. Section is like where you cut a part down the middle, right? And you look at it from one side. And so this is it kind of looks like a section. I mean, you could be fooled that it looks like a section, but again, you're definitely not seeing the whole part. And last, crop, of course, well, you're only seeing part of the section, or part of the part.
Yeah. I think section view here would be HH. Mm-hmm. So if you look at this one, see how it's cutting through the part itself and then showing that view? That would then be a section, or HH.
Well, actually, this whole thing is actually a section.
Oh, is it?
On the left is a section view.
Oh, okay.
And then NN is also a section.
Okay, yeah. So what Abe said. And so section views will cut in the part, and you'll be able to tell the inside of the part, basically. And that's good for if you have holes in the middle and you want to get the dimension of the hole itself. Rather than using like hidden lines to show the outline of the circle or the hole, you can just section view cut it and then see the hole in the actual body of the part.
Okay, this is second practice problem. We'll take another 60 seconds. Okay. What do you guys think? That wasn't a minute, I know, but yeah. What do you think? You say C? Okay. Why? Okay. Okay. No, that's good. That's correct.
Oh, yeah.
Oh, yeah, that is correct. It is C, a broken out section. So a broken out section is where you can see the overall part, except for a small spline. It says spline. It's just basically like an enclosed sketch, and then that cuts into the part, so you can see the inside of the part. So yeah, that's correct.
One thing, I don't know if we put it in here, but the exam, when you take it, it's proctored on your own computer. Proctored meaning it's a software that they provide, and then you download it and take the exam through that software. However, you are able to Google the answers, not directly the answers, but more so what you can Google what in the line section is, Google what a detail is, check out what a broken out section, and then compare it to the answer and say, hey, does this match here?
And also, of course, you're allowed to use a SolidWorks help function within SolidWorks, like the documentation. So that's effectively the same as Googling. So, because if you're going to Google what an aligned section is, you're going to go to the online SolidWorks documentation. So
yeah.
Either one is fine.
So don't stress too hard about this portion of it. It's definitely just more of like do you understand what the drawings are showing? And a lot of this process of elimination, you can, through the words, it's broken out. Like it doesn't seem like an line, it's not like straight. So you can sort of narrow it down that way. It's really, this is like the easiest part of the entire test so far. Now we'll get into the more fun part that I think you all are here for, which is the actual part modeling. Okay. So I think everyone has the problems. If you don't have the problems, please let me know right now. Anyone not have the problems that we'll be working on today? Okay, cool. So we have about an hour and a half to get through a couple of these problems and an assembly. So our goal is to do 2 problems and 1 assembly. If we have more time, we'll go back to another problem. If not, that's okay. You guys have the problems. You guys can work on them on your own and ask us for help afterwards. We've also included the answers so you can check your maths afterwards. And yeah, if you have any questions, let us know. So for now, we'll start off with section A, problem 2. This one should be pretty simple. It's nothing too complicated. And if you have simple CAD experience so far, It should not take you that long. This is going to be a problem that's easier than you'd see on the exam, but it's definitely a good place for us to start off because it helps with understanding how to work around the model and not just in a single right, top, and front plane sketches. What we'll do is we'll do about, I'd say give you guys 7.5 minutes to work on this on your own. And then in 7.5 minutes, we'll come back and I'll start modeling through it. And you guys can follow along. If you have any questions, raise your hand and Abe will come by and help you out. And also, the model is up here on my left. Oh, yeah, it works out. Let's do that. Okay. Yeah, so 7.5 minutes. Good luck. I mean, sure. I think any timer, like any timer website will work. Yeah, I'll come around and give help. You don't have the problems email? Do you want to email it to him? What? You want to, he needs the problems. Wait, so you didn't get the email at all? Okay. We sent out the email last night at 10:20. Did you send up after 10:20 p.m.? Okay. Just go to like the last person who responded to our session form then. If you want to just forward him the email we sent out last night, that would work too because it has the attachment. One thing I want to point out, when you're looking at these drawings, it is good to note the units that they're using. And generally speaking, I believe it's like mmgs is what the standard they use is. However, one way to tell quickly if it's millimeters or inches is look at the size of the numbers. If the numbers tend to be double digits or higher, say at 15, 24, 16, or you might have like 30 or 40, your chances are you're in mmgs. That's the units they're using. If the units tend to be really small, like 1, 0.5, 3, 2, you're most likely in inches. That's just by looking at the drawings, you can easily tell what the size is. But it'll also tell you on the top or on the side in the part if it's mmgs and the units and everything. So just make sure you note that because if you get that wrong, then your part mass is going to be completely off. I can zoom in for y'all as well. Is that better? And if you guys have questions right now, you can feel free to like raise your hand and we'll come out and help you guys. it's not compatible, it's just numbers. That's the line right here. 45. Is this cut? Yeah? Just for that. Oh, okay, you're not really doing it. No, it's like that. I think it's probably good. How do you get the file typically? Okay. We should probably log out. Should we log out of it now? You don't have a solver camera right now, right? You have that? Okay, nice. Can I keep the work? Oh, wait. I don't think there should be no caffeine in there. Oh, because iced tea. All right, all right. That is 7.5 minutes. Let's come back together now. So I was walking around and I could see some of you guys struggling a bit more with the thought process on how exactly is the best way to go about this, trying out different boss extrudes, different cut extrudes. That's good. That's what you should be doing right now, is trying to figure out the best way to go about it. And it's all right if you guys don't have it fully formed yet. That's what we're here for. That's what we're going to help you out with today. Before I get into actually how to model this part, anybody have any questions from their time right now? What were they more confused on, or what were they struggling with? So I know when I go through it, I'm able to hit those points. And chances are, if you're struggling with something, someone else in this room is also struggling with the same thing. So feel free to just, raise your hand, let me know. No one? Everyone was good? Yeah. Time. That's fair. No, not a problem. So for reference, I have been using SolidWorks for, I think it's my 6th year now. 6 years. So for me, I have a fair amount of experience with the software. And so this part, I can probably do in 5 minutes. But that's only because I've done it so many times and I've practiced so much with this. So don't worry that you can't do it in 7.5 minutes. This is a really short amount of time. And the reason we gave you such a short amount of time was, well, one, we only have 2 hours for this workshop. But number 2 is, I don't want you guys to go so far down a rabbit hole and then realize that you're doing it wrong. So I want to give you guys a taste, a way to sort of feel out the problem, read the drawings, get an understanding of what's being asked, and then when I go over it, you guys will have the understanding and follow along more easily with what I'm doing. Are there any other questions, comments? Haven't anybody realized anything, any questions about the drawings, anything that was confusing to you guys? Yeah. Okay, that's not bad, yeah. I wouldn't recommend, for now, trying to worry about that too much. I think that's more like a understanding, once you know how to build a part and the different ways to do it, then you can figure out how to do it in a few features. I think for now, your first goal should be, how do I get the part made accurately? But that's not a bad idea to keep in mind. And when I do this with you guys, I'll show you guys how to do it in 3 features. So you guys can see the process that goes into that.
Right. Also, the exam only asks you for these parts. It only asks you for mass. So you don't need to worry about if you hit 4 features, 5 features, whatever. As long as you get the correct mass, then you're fine.
Exactly.
It's just it's just to consider. You can make it in 3 features.
Yeah. It's a little bit like a little bit of an extra challenge. All right. Any other questions before I begin? All right. With that being said, I will start this. Keep in mind, during my going over this, please feel free to just raise your hand, ask questions. If you're struggling within SOLIDWORKS itself, raise your hand and Abe will come to you and help you out. If it's more like a conceptual question or more of a, wait, what are you doing here? I will answer that question for you guys too. So let's do this. One thing you're going to notice I'm doing is Alt-Tab. If you're on Windows, Alt-Tab will switch between your 2 latest screens. So if I do Alt-Tab, you can see all the screens I have open. And so I can just go between SOLIDWORKS and the drawings really fast and really easily. This is something that'll help you guys out probably in the exam itself, unless you have like 2 monitors. If you have 2 monitors, you're chilling. If you have 1, you just want to Alt-Tab. It's fast, easy, and you can quickly look at what you need to see. So let's do, okay. All right, so what am I looking for when I first open this up? I'm looking for the basic geometry. I'm trying to analyze this in 3 planes mainly. Like, what are the 3, like, how am I going to construct this? What are like the sketches I need to create this? And so when I look at this and I see this drawing, the first thing I think of is, hey, I can build all this geometry right here in 1 sketch. Not thinking about the different levels of boss extrusions that need to happen. I just think if you take a silhouette of this is just 1 sketch, all this can be made in. So in my head, I'm like, okay, this could be a good starting place right here. Looking at this, that will get me a good majority of what I need to get done here. And then I can focus on the 2 knobs afterwards. I saw some people trying to work it from the other side, from the front face going inwards, outwards. And that's one way to do it as well. That would work. You could do it that way and then just sort of cut into it from the side. And that's definitely a valid way to do it. But for me, I'm trying to think about extrusions, because extrusions will help limit the amount of features you have to do. With additive manufacturing in SOLIDWORKS, it's a lot easier to build up rather than cut down. By that, I mean it's better to try to extrude something rather than have a big block and cut into a block to create what you need. And so let's start that. So what I'm going to do is I'm going to create a silhouetted sketch of this image right here and dimension it accordingly. And then I'll show you guys what to do from there. So the first thing you want to do is, looking at that was in the right plane. So I'm just going to sketch in the right plane. And we always want to use the origin, of course, when we start the sketches. So I'm going to use it as the bottom left point right here. It doesn't matter bottom left, bottom right. Just want the origin somewhere in your sketch. Oh, but before I begin, notice how in the bottom right it says IPS. That means I'm going to be in the wrong unit, so I want to make sure I click that and switch it to MMGS to ensure that when I model this, the dimensions will be correct. So going back to the right plane, we can see that it's telling us to go across, up, and then diagonally that way. I'll try to talk through this as I do it. It will be a little bit hard because when I model, I don't normally talk out loud to myself. So if at any point I don't say something and I'm doing something and you have a question about it, please just call it out. I'll be happy to explain what I'm doing. This first step, I'm not trying to get accurate to-scale measurements. I'm just trying to get the rough outline. Notice how the degrees aren't going to be perfect, the lengths aren't going to be equal. It's all a matter of the rough outline. So looking here, I have 2 options. Either I can come down going this way and then build this part, or I can go around. It does not matter. This is just a sketch. You can do whichever option floats your boat. So for me, I'm just going to come down here and then go across and come down. And then I'm going to do this part by going up a bit, this way, up, and then across. Okay, this is our very rough sketch. If you can tell, it looks nothing like, well, it looks similar, but not quite what's shown here. Everyone good so far? Anybody super lost? No, didn't lose anybody? Awesome. So from here, now this is where we start dimensioning, adding relations. I'd recommend adding relations before dimensioning. It'll help make your process easier. Does anybody not know what a relation is? Okay, cool. If you don't know, that's okay. Just raise your hand, Abe can help you out. So I'm going to add horizontal, make sure these lines are horizontal and vertical. This is corner, okay, we're looking here. These should be perpendicular. That's fine, this is vertical, that's horizontal, it's fine. And looking here, these lines are equal, this one and this one. We just make that equal real quick. Okay, now we're going to add dimensions. So I'm looking at the bottom, we have 78. So we want to hit smart dimension. Come here, 78. Again, because it's a big number, we can tell that we're in the correct units because it's millimeters. Then this is going to be 36. 24 and 16, so this is going to be 16, be 24. So things are getting a little wonky. That's okay. Don't worry about it. Just keep adding your dimensions. Everything will sort itself out. And if it doesn't sort itself out, then you can fix that by redrawing part of it or redimensioning part of it. That will help reset what needs to be reset. 65 degrees. So we're looking at a width of 5 here. And then, so okay, what I've done so far is I've sort of just looked at this one sketch. So that's 15. So that's the last bit I could add here. But there's so much blue. Blue means that it's underdefined, and we want it to all be black. So what do we do here? We have to look at the other two sketches that it provides us. Look at the other drawings and dimensions, and then figure out from there. So looking at here, this bottom left one, I see that the height of the line here is 16, and then it's 18. So that's referring to these two, I believe. Or actually, it's referring to this line with this one right here. This is going to be 16, as shown here. And the reason I know it's not this midpoint line that's right, the reason I know it's not this line right here is because if we look here, we see a smaller line and this top one. So I'm just realizing that this is what that middle line right here is. And the second one is going to be this line right here. And then we see that's 18 above here, so we can easily dimension this to be 18. And right away, we're getting a lot more black, which is great. Now we look in the top right here and see what we can find. I don't know if we can find too much. Oh, we can add this right here. This is 58 high. So it's looking like from the top point right here, this edge, this corner edge down is 58. So by going back to smart dimensioning and then adding this dimension there, we can make this 58. So we're still missing this. Now we look back here and see what can we see that will give it to us. And I realize this is midpoint right here. It doesn't give us an exact height, but it tells us it's between these two lines. So we can find that midpoint by, okay, so see, this is where like your geometry and sketch comes into play. There's actually no midpoint between these lines at the moment because this was two different lines that I drew. I didn't draw this in one line, one go. So there's two options. Either I can delete this line entity and then draw it again as a midpoint, or I could just divide the diameter by half, or the length of the segment by half. For now, I'm just do half, and that's fine. If you're working with global variables and things that need to change, you want to make sure that this won't affect any of that. And we'll go into what global variables are in a bit. But for now, we'll go back to dimensioning just this one to half of the length of 16, so that's going to be 8. And that midpoint's that line right there, and we should be good. So notice how everything's black. At the bottom it says fully defined. We're good now. We have our main sketch done. Are there any questions? Another reason why I chose to do this sketch first was it looked like the most complicated one. Getting the most complicated sketches done first will definitely help out later on because that's where all your mistakes will probably lie. So if you get that done well and correctly, all your dimensions there, the rest of it's just easy. Okay, so moving on from here, let's exit the sketch, and we want to do an extrusion. So we want to do features, boss extrude, and the sketch is selected. So we want to select the area, so the contours, and it's going to be, we'll start with this area. It doesn't really matter which one you start with, but you're going to need 2 boss extrudes on this one sketch. I'll show you how to do that. So we're doing this thicker area, and looking at this one right here, this bottom left, we see that the thickness is 28 millimeters. That's the total depth, I guess, of this part. And so hit 28 for the depth here. And then we have this little bit that we need to do still, so we can just click this arrow down here, click Sketch 2, and extrude boss base. We're able to now click this new area, and we want to look. It is a depth of 18, so we're going to change this from 28 to 18. And bam. There you go. So that's the majority of your part done. And we've only used 2 features so far. So we have 1 more to go. Now the last part we need to do is add these little knobs at the top here. And that's done with these circles. And I hope all of you guys know how to make a sketch on a plane. If not, I'm about to show you. We just have to rotate around. So I'm doing this by holding the middle click button to rotate around the part. Click the face that we want to sketch on. And then, so I left click on the face and then left click the sketch icon. And now we're sketching on this face, which looks weird, again, like the angle at which we're looking at it because it's an angled face and not a straight down top face, but you trust that we're sketching on this face. So the 2 circles of 6 diameter, 7 inches from the side, and 750 from there. A few ways to go about this. We can just start by sketching out these circles. And I'm going to zoom in, and we can add dimensions. What I'm going to do is, since they're both the same dimension, I'm just going to dimension one of them and then put an equal relation. This means that if we need to change both of them, it's really easy by just changing one dimension. It'll help us out if we ever need to go back and make edits. This is only good if you know that both of the knobs should be the same size. And it's more of like an application in when you're modeling for a car or modeling for a part. If you know that 2 things need to be the same size, use the equal relation. It makes your life a lot easier and makes the sketch a lot less messy. So going here, we're going to just add 7 from the side. There are, again, cleaner ways to do this, but for now I'm just going to do it one at a time because the cleaner ways might get a little bit confusing. And then 750 from the top from here. Now okay, so we know that this is 750 is halfway through because we see the 15 in the bottom right sketch right here. But let's say we didn't know. We'd want to probably make sure that we're doing it from this line right here and not from this bottom one, just in case. In case it's 16 and this should not be centered, we want to make sure we're hitting the correct line. And that's going to be this line right over here. And so in our sketch, it's this one that I'm using right now. And that's 750. And both of them are in line, so I'm just going to hit the center points for both of these. I'm holding Shift, clicking both center points, and clicking the horizontal. Now they're both black, means they're both fully defined, and we will extrude these. So extruding them, it says right here it's 6. So we'll just go here, make this 6, and we're good. And so now we have our part basically modeled. Last thing I want to do, and this is going to be important for the exam, is you got to add your material. It does not matter if you add your material at the beginning or at the end. It really doesn't matter. So I'm just going to add my material now. It says it is iron, ductile iron, and the density is 7,100 kilograms. So I'm going to right-click on the material, click Edit Material, and I just need to look through the materials that SOLIDWORKS provides to find where it would be. So it's an iron, ductile iron. I'm just going to make sure the mass density right here, 7,100, that's correct. It should be correct. It should never be wrong. If it's wrong, something within SOLIDWORKS is probably wrong. So it's just good verification, making sure you selected the correct material. So apply, close, and now we can go to evaluate, go to mass properties, and we see that the mass here is 497.28 grams. If we scroll to the bottom and look at the answers, the answer should be 497.28 grams. It'd be really embarrassing for me if it was not. In any case, do you guys have any questions about this? I know I sort of went through it. No one really stopped me, but if there are any questions, now is the time to ask before we move on to the next part. Yeah? So did that answer your question, by the way, of how to do it? It was your question about like how to do a few features? It really starts off with just finding the most complex sketch and then doing it that way. Yeah? Yeah, so the only time it won't work itself out, it's really annoying when this happens. I'll show you guys with a quick part here. It's more so when you have notice how when I modeled part of it, like one of the lines went down lower than another line. If you're to add a dimension between these two then, it might push this bottom line up higher when you want to flip around. So that's just something that might be a little annoying. I'll show you what I mean real quick. Like if I have a... It could help, yeah. So if I do something like here, and then I want to do something like this, for example, and then I measured this to be, because this is going to be 0.69. So if I want to be in this order, and I go here, I write 0.5. Oh, what just happened? Oh, okay, so it's a degrees, and that's because this was not a straight line. So that's one issue that might pop up. So you want to make sure that your lines are going to be straight. Let's make sure this is straight as well. Okay. Yeah, so going back to the dimensioning, so if I go here and do 0.5 degrees, or size. Okay, well, everything stays relative, but if I were to, okay, well, kind of defeats the point. But this might happen, something like this where it changes, that might occur. And then you need to move it down manually to make sure it stays between your two lines. It's not hard fixes, it just gets annoying. But if you had the dimensions, like I showed you making it horizontal, that'll help with the angle situation. Or basically, long story short, do the relations first, then do dimensions, because that'll make sure everything's constrained properly, especially with your perpendiculars, your parallels, your tangents. Helps with you doing circles and lines. You want to make sure they're a tangent, because if they're not, they'll come apart or they'll be connected in a weird way. And that'll get really ugly. Okay, are there any questions? Any more questions? Did everyone sort of follow along with how that part was modeled? Anything confusing in that regard? Okay, are all of you guys ready to move on, or do you guys want some more time with this part? I'm good for both. Raise your hand if you want a little bit more time with this part to figure it out on your own. Raise your hand if you want to move on to the next one. Okay, there are a few of you guys didn't raise your hand. Do you guys have a preference or no preference? No preference? Okay, let's move on. If you're still working on this, that's okay. You can also, I'd recommend sticking with us for the next part and then come back to us later and then ask us your questions afterwards. In the meanwhile, I'll pull up the next part. And for this one, this is going to be Section E, Problem 2. Would you guys prefer if I just model it right now for you guys, or if I give you guys a little bit of time to work it out on your own? Show of hands, raise your hand if you want the time on your own to work it out. All right, cool. We'll give you guys, say, 10 minutes for this. What time is it right now? Yeah, let's do about 10 minutes, so until 7 o'clock. We'll give you to 7 o'clock. Work on this part. Here, I'll zoom in for you guys. You should also have the PDF on your own laptops, too, if you want to just look at those. That's easier, but here you go. The part is in MMGS, just so you're aware. And then the material is right there. Yeah. And if you have any questions, just raise your hand, and we'll come by and help out. again. If you have any questions, please raise your hand. We'll be happy to come by and help out. Towards the end, after we wrap it up, we'll show you that's what's up there, and just go down and figure it out. But we'll show you guys right at the end. That's fine. Well, I think it's in the email. If not, we'll resave it in the next email. And we'll try to upload the recording at some point, and we'll send a notice for that. So if you're in the Slack, you'll get the notice. Oh, perfect. Okay, have a good one. It's E. Okay, that is 10 minutes. How are y'all feeling with that? A little more complicated than the previous one? Yeah. It sucks that we only have 2 hours with you guys because we had to jump from something simpler to something more complicated, and that's really hard, especially without the in-between. If you look through this PDF on your own, the ones that come in between these, I think there's like a section B problem and section D problem, those should be a little bit more intermediate level. I want to say this is slightly more complicated than what you might see on the exam itself, but it's one of those that are really helpful for understanding how to create a sketch. Okay, so before I get started with this problem, what were some of the issues you guys faced, issues you guys had, questions you have when doing this part modeling? Yeah. Where to start the sketch, right. Do you mean like which side, or do you mean like just which part to make center point, or like on the origin?
Yeah, where to start with center point and the face.
Okay. Yeah, comments? I saw someone else hand up, go up. Same, you have the same thing? Same thing. Does other people have the same like struggle there with like where to start the sketch? Yeah. Okay. Are there any other problems you guys faced, or was it just mainly, yeah?
Like a little bit after the sketch, trying to figure out the straight line inside for the abstract ideas,
Mm-hmm.
and how to, I guess, get the curves to correlate correctly.
Yeah, definitely. Okay. Yeah, we'll go over that with this too then. All right, anything else? All right, well, let us begin. This is going to be a little bit more of a complex one. I'll try to talk through it again like I did last time. Did that work for you guys while I was just talking through what I was doing? Okay, I'll do that again. If I'm going too fast, please tell me to slow down. Ask your questions. Abel can come around and help you guys out. But yeah, let's begin with this. Okay, so when I first look at this model, what do I see? They give us two main faces to work with, and then just like an image of what it should look like after it's finished. And when I see this, I'm thinking in my head, okay, what are some of the ways I can go about modeling it? And one thing I think about is, oh, maybe I can use some sort of like mirror plane. I can do a mirror plane in the middle and flip it over. Then I look at it and I'm like, I don't think that's strictly necessary. I feel like you can either make it one go extrude backwards and then cut out what you need, or extrude this way and then cut it out that way. Remember how I said you don't want to create a block and then cut out of it? This doesn't necessarily break the rule. It's not an exception to the rule. Still stand strong to that. But this is one of those times where you're going to need to make a thicker block and cut stuff out of it. We're not making it like a rectangular prism and we're cutting out all of it. We're sort of deciding which face do we want to extrude first. Do we want to extrude this sort of shape first and then cut out the holes here? Or the other way around, model this sort of general shape and then cut out these holes. Both will work, and I think both will actually get you in the 3 features that it tells you to. I think there's one better way to do it, but both will work. Can someone guess which way might be the better way to do it? Which face? Should we start off doing this one and then cut out that, or model that, cut this out? Left one, model left, cut out right? Yeah. So going back to what I said about complexity is we want to do the sketch with the most complexity, and to me, yeah, looking at that left one, that looks more complex than this right one. So let's start off, and we'll start sketching this on the front plane. So let's see. Okay. So looking up here, we have, okay, MMGS, titanium alloy. For this one, I'll actually just set the material first, because it doesn't, oh, my bad. It does not matter what order you do it in. So titanium alloy, we're looking at Ti8Mn annealed, Ti8Mn annealed. Just check real quick. Your density is 4730. You're good. Apply, close. All right, next thing, IPS. Let's change to MMGS. There's also a way if you just ever want to work in MMGS, which honestly, my preference is MMGS. It's just recently I've been doing a lot of inches and stuff for class and like projects and stuff. I prefer MMGS, and there's a way to change your default. If you have a question about that or how to do it, I can help you out later. But this is a really quick, easy way. Just click the bottom there and change it. All right, front plane. Let's do this. So starting off here, when I see circles, I immediately think, hey, I want to put the center point of this circle on the front plane, or sorry, on the origin. That way it just makes it concentric, and it's really easy to dimension everything off of that. So I'll start with this top. It doesn't really matter if it's bottom or top on the origin. I'm just going to do top because, I don't know, that's what I prefer. And so we'll just start off with the rough sketch. So we have 2 circles like this. You could also do it with a circle and an arc, but actually a circle arc might be better in this case because you have an R. When you see an R, you know that's a radius. And R generally means like an arc that you're using. And when it's like this sort of shape, that means diameter. You can achieve the same thing with circle and circle still without using the arc. Then we have two lines coming out this way. You see a curve here. That can either be a fillet or it can be a 3-point arc. For now, I'm just going to make two lines, and we'll figure that out as we go down. Actually, looking at this right now, I realize that these two sides are actually identical, meaning we can mirror it, and we don't have to draw both. We can just draw out one side and then be good that way. So, by the way, if you ever like rotate your plane accidentally, if you click this normal 2 button, or I guess it's here, and click normal 2, it'll just make it so it's flat, your face on the plane again. In any case, I'm just going to draw a center line. This one does not need to be dimensioned. It's just going to help me if when I want to mirror it afterwards. So center line, and then I'm going to look here and see that this is a straight line, and it comes down this way. Once again, you have some sort of arc, but I think I could do it with the sketch fillet. So we're going to connect it here, come down this way, and then come this way. We have another circle that's on the center line, so we'll just plop that somewhere here. I wanted to avoid, you notice like when I put my hover here, you see like a yellow point. I want to avoid putting my circle on this yellow point because that's going to create a relation between the center point of the circle and the midpoint of the center line. And that's a relation that I don't really want because I don't know what that means for my sketch, and it's going to be complicated to dimension because that relation will stop it from dimensioning properly. So I'm just going to make sure it didn't connect and we're good. And now we have a general sort of gist of this overall shape here. So looking at this, we know that we'll start with the circle. So we have 20 for the diameter in the middle here. So smart dimension, and then 20 millimeters here. And this radius is 25, so we know that's going to be a diameter of 50. And we'll do the bottom down here too. This is a 20 and... Okay, so this distance actually is not the diameter. It's a distance between this arc-ish and that circle, which is perfectly okay. So we see this is 20 for the diameter. And these two, you click on both to create the distance between both of them, and set that to 20. And now when we look down here, we see that this is a straight line that goes right into the circle. So we know that has to be tangent. And so we can just click here, shift-click the circle, and we can make sure that it's a tangency component. So we changed it from coincident to tangent. Coincident was just that the line intersected the circle. Tangent means, as you guys know what tangency is, it just means that it's like one point of intersection between the entire line and then the circle. And that means that if we were to like shrink this, for example, to make this 10, the line remains tangent to the circle. So back to 20 here. And then looking at this point, we have, so this is 60 degrees from the center. Or sorry, 60 from side to side, so 30 from the center, and that's 45 from the center. So we can go ahead and smart dimension these two lines right here. This is going to be 45 from the center, and this is going to be 60 from this, or sorry, 30 from the center here. Now, because it looks like it's getting a little bit close, it's hard for me to really see the dimensions. I'm going to add the height dimension to spread it out. Looking at, okay, let's see where to look here. Right here, we have 100. It's between the two center points of the circle. So we see, okay, from this point to this point, we can do 100. Now, one way you could have done this as well is, notice the center line I have here. This could have been connected at the center point, like the end to end. And then you could dimension that center line to be 100, and that would also change the height of this shape. Either way works. It's up to your preference. Anyway, everything is black. It's technically fully defined. However, as you can tell, it doesn't look like our model yet. So, looking at this, let's figure out what else we need to do. So we need to add these fillets. So this is 10 degrees. But before we do that, I want to make sure that this part right here, this connection, is correct. And currently, it doesn't look like it is correct because this should not be tangent to the circle. So I'm going to delete this right here. I'm going to remodel this where off the circle, I'm going to do a 3-point arc. So clicking this portion, that's this point on the left side of the circle, and then clicking a random arbitrary point here, create a 3-point arc, like so. And then I'll create a center line, or just a line from here to here. Now we'll smart dimension, And we'll do this at 45 degrees. And we know this should have a radius of 30 degrees. And then we want to look at here, and we know that this line, this one looks tangent to this circle, so we can make that tangent right there. And notice how it's still very much like, we can still move this around. So we need another dimension here that'll help us out with this moving around aspect of it. So let's see, what can we find? Is it tangent to this? Oh yeah, sorry, I should make this tangent. Thank you, Abe. Yeah, so these two should also be tangent. And once you do that, now the entire thing flows in one go. So from the circle, it flows down to this line, and it looks smooth just as it does right here. Now we want to add the last sketch fillet. The reason I save the sketch fillet for last is that destroys some of your existing geometry. And so you don't want to do sketch fillets until everything else is fully defined. It'll just make your life a lot easier if you do it that way. Save sketch fillets for last. And the last thing is we look here, and it's a radius of 10. We're good. Now the final step is just to mirror all this over. And that's really simple by just using the mirror entities tool and clicking these. You don't want to, I mean, you can mirror the circles, but it shouldn't do anything at all because it's just mirroring on itself. I'd recommend just avoiding doing that in case it creates any overlapping geometries. So once we have it here, we mirror, everything is all good. And now we are ready to extrude. So it's a complicated face, and now we're able to extrude all this area right here. And we look at the depth, and the total depth is 45. We're going from end to end, and it'll cut out what we don't need afterwards. So 45 degrees, or 45 millimeters. And that's our block. So that's a giant block that should be this. So if we go to Control 7 view, Control 7, by the way, is isometric. Looking at this, this looks roughly the same shape and parameters as this shape right here. So we're doing good. Next up is to go on the right plane. I can't exactly click any faces here to extrude or to cut into because they're all slanted faces. It'll make life really difficult to do it that way. So you just click the right plane and sketch on the right plane, and then you'll be good. So looking at this again, we see that we need to do some sort of, what's it called? I guess a curved and a rectangular prism here on both sides, and then this part down here. This looks identical, so I can just actually mirror it like I did before. So create a center line. If you hover over the line, you'll see the yellow dot. That's the midpoint. We come down, and now we have this. So 12 millimeters. We can start drawing out our shape. Remember how I said before your drawings don't need to be accurate? This is another instance of that. You don't need to be exactly what it says, just somewhere in the right area. I'm going to try to do this with a sketch fillet because it's just a simple arc. And we'll see if this works. So if I do smart dimension, this to be 12. And then we have the height of this is 65. And then this is a radius of 25. So if we go to sketch fillet, go here and make this 25. Okay, let's see. So that would not work. And since that doesn't work, we just have to delete this line and create an arc. Yeah. Okay, that's fine. So looking at this 25 degrees, 12, we're good there. We just want this line to be straight down right here. And then we're going to smart dimension, or not smart dimension, we're going to create a relation between this line here to make it tangent, and this line, and that's fine. And then we're going to smart dimension this to be 25, radius of 25. All right, now it's all black. Now we're good. We can take all this. So I'm just left-clicking down, highlighting all of it. I'm doing mirror entities, and I'm going to mirror all of this about the center line. And it lines it perfectly on that side, so we're good. And the last thing is to add the cut down here. So this one's also really simple. This one looks like it's more of a sketch fillet because the two corners look identical in terms of the way they're rounded out. So I believe using a sketch fillet here would work. So I'm going to do a rectangle, and I'm going to model it like this. And yeah, so let's do it. So 25 degrees for the width of this rectangle. And then your height of this rectangle will be 92. And that lines up, okay, 92. And this should be a center line, so I'm just going to make it so, hover over here, select that yellow dot, shift, hit the center line, and make this coincidence. And that fully defines everything. That sort of shifts it so the midpoint of that middle line is coincident with that center line, so it's all symmetrical. And then we want to round these out, so sketch fillet here. Okay. That's fine. 10 millimeters and here. So we're good. And we'll do a, exit that. We'll do extruded cut. And we're just going to cut. So notice how, okay, so the right plane is direct center. And so the issue this creates, or it's not really an issue, but something worth noting. If we look at this right plane, it's right here in the center of the model. So we can't just do a blind cut one way. We have to actually go ahead and change our cutting parameters. So it's not blind one way, but it's through all, both. It basically makes it so it cuts all the way through the entire model, going forward and backwards. Select that, and now we have what looks like the correct part. So Control 7, isometric. It looks similar to what's shown here. I wouldn't worry about the glossiness. That's just your decal and your material properties. That won't affect your mass or anything if it looks like shinier than the way it looks in the actual model. Going to evaluate, we're going to check the mass properties here. It's 1088.47. Scrolling down, we're on section E. Oh, thank you. Yeah, so one thing I did miss, and thank you for pointing it out, is the chamfer that's located 45 degrees right here. So it says 4 by 5 by 45. Does anybody not know how to read what a chamfer means or what this means right here? Okay, cool. So I'm going to add 4 chamfers, and they're going to be 5 millimeters with 45 degrees. So features, fillet, it's under fillet, chamfer. So we're going to just select all of these parts right here. We want to make sure we don't select the inside portions here, and we know that because only 4, and also it's only shown as like the outsides. And then we're going to change this to be 5 millimeters. Default's 45, so we don't have to worry about that. Select that. Now we're good. And so now when we check the evaluate and the mass properties, we're at 1071.13. And the actual one is 1071.13 grams. So we are good here. And thank you for pointing out the chamfer. One thing to note is, yeah, double checking your part is very important, and recognizing if you miss something like that. Sometimes the mass will be a multiple choice question where you can select which mass. And so if your mass does not match one of the ones listed, that means you made a mistake somewhere. Other times the mass will be a fill in the blank, and you have to enter your own mass. I believe, generally speaking, it's multiple choice first, and then as you update your parts, then you fill in your own mass. So it should be relatively simple to figure out if you did it incorrectly. You can get your mass, you can get it correct if your mass is within 1% of the actual answer. So if the answer is like 1072 and you have 1071, you'll still get the question correct because you're within 1% of the actual mass. However, the problem that may cause is later down the line, if you're updating your model and changing up certain dimensions, that mass may be bigger than 1% of a difference. So try to get it as close to the actual mass as possible. That was definitely a lot more complicated than the first one I showed you guys. It took a little bit longer for me to go through it. So does anybody have any questions whatsoever about this model or about anything I did during my modeling of this model? Yes?
Can you go back to when we did the right side sketch and cut through the side of it?
Yeah. So I'm going to go here, edit sketch. So this is what I did here. So I started with, so actually you could do this in a couple ways. With SolidWorks and with modeling, there's so many different ways you can go about doing something, and you just choose which one works best for you. For example, I could have done like half of this right here, done this half and mirrored everything all over together, and then cut everything, and that would have been fine. I just chose to do this part, mirror that, and then do this in one go because this is just a rectangle with rounded corners. So it's really simple for me, just rectangle and fill up the corners. What was your question? Yeah.
That's a similar thing, but can you go over like, the difference between through all and through all?
Sure. Are you good with this? Yeah. Okay. So let's go to the feature that I did right here. I can quickly run through what the different ones are. So a blind is you setting out how much of, A blind is like this. It just goes one direction, however far you want to go. However, you could actually make this, so this option here that says direction 2, and you click it, it'll go both ways, and you can change it. So if I want to do 45 millimeters in one direction, and I want to do like 10 millimeters in a different direction. No. You can do this way, which is a little bit one way, a little bit more the other way. I don't recommend that. It's complicated. It's ugly. You just want to stick to blinds if it tells you to go a certain depth. Through all is good if you want to go all the way through. And through all both is what I showed you with direction 2. It starts direction 2 and sees a through all right here underneath direction 2. And that's through all both. It just means it goes both directions, forward and backwards. This only really matters if you're modeling on a plane that's centered in your actual solid body. If this right plane, for example, was on this side, you'd only need through all to get through the entire part. Through all both just means through all, but in both directions. And then you have the other ones, which is like offset from surface, up to next. Like, they just do different things. So mid-plane, for example, would mean that it's a blind, but it's 45 degrees total. So it goes 22.5 in this direction, 22.5 in this direction. That's a mid-plane. Yeah, so for example, if I want to be really fancy with it, I could have done this as a mid-plane. Because right now, if you look at this front plane, it's on the back side of here. If I want to be really fancy and really center this part at the origin and everything, I would do a mid-plane. So the front plane would also be centered within the model itself as well. So the right plane would be centered and the front plane would be centered. And that would make it really fancy. But that's not really necessary for this model. That's a good question. Any other questions? Yeah?
When you're making a part based on like the sketches they give you, is there anything you're looking for when you choose to use a sketch fillet versus like an arc, or can you use them for the
There's definitely differences. You saw me sort of work it through here because I was trying to figure out which would be best to use. So this, when I see something like this, I think sketch fillet because the sketch fillets won't let you go past, how do I say it? If you're rounding a corner and you're like 12 millimeters apart here, you can't sort of go past that point. Like you can only do a fillet that goes from one side to another side. With an arc, you can go past that point and it'll redefine it properly. So over here, this shows me 2 center points and a straight line at the top here, which means you could have done an arc on both of these, or you could do sketch fillets. Because they're the same radius of both of them, and this is, I guess, an assumption you have to make, is when it shows you something like this, you see both radiuses, or it gives you one radius, you have to assume that is for both. I guess it won't directly tell you that it's for both. For something like this, I tried doing a sketch fillet, but a sketch fillet is usually like a 90-degree arc, and so this itself right here, see how the center point is way off? It's not going to, if this was more in line here, then it'd bring this side up, and then that would be like a sketch fillet, like this. So I guess you just have to sort of look at the arc itself, and you can try one out, and if it doesn't work, just change it. Like I did that. I tried a sketch fillet. It didn't work, so I just changed it for an arc. But yeah, if you're really trying to be as efficient with it and not trying to make those errors, just sort of look at, if it's like a 90-degree arc, you think sketch fillet if you see multiple corners, especially. If it's like a one arc like this, you could think use a 3-point arc. Center point arcs, you'd use sometimes. I don't know. Center point arcs are like, they're really nice to use. They're really easy to use. But at that point, you can use a circle and then just trim out a circle too. I don't really use tangent arcs too much. It's mostly 3 points, especially for an exam like this. That's the one you'd be using. Good question. Anybody else? Okay. What were some of the key things you noticed when you were modeling on your own compared to when I was modeling it? What were some things that you noticed that were different? For those that were struggling with how to start the sketch, did that help, by the way, like answering that question of how to start the sketch? Okay. I know someone had a question about, what was your question about how to, was that the extrusion or? For this one. Did you have a question about, I forget now. Okay. Oh, you're good then, no worries. Anybody else? Any questions, any comments? If you had to rate yourself on being able to complete this problem, raise your hand if you think you could have completed this on your own as you are now. Okay, so for those of you that raise your hand, that's pretty good. You're in a good spot. I think with a little bit more practice, you're definitely ready for the exam. If you're not there yet, that's completely okay. I think, again, with more practice, you'll also get there. It really is just practice when it comes down to it. The more you do, the more experience you have. Like, I've tackled so many problems with these similar issues And once you do the same issue over and over, you're like, okay, how do I get around this easily? One of the things that help make your designing faster is shortcuts. I don't know if you guys noticed, but I would accidentally do some shortcuts where if I'm sketching, to make things a little bit faster, instead of like going up here to click a new sketch tool, I can go to here. This is where I hold a right click. I can like quickly hit a line tool. I can hit, for example, I would hit like a square, rectangle, circle. It helps me make things really fast. I can quickly smart dimension without having to go all the way back there. However, for this exam, you really don't need to do any of this because you have 3 hours, which is plenty of time. For something like the CSWP, you may need to be able to model faster. That's definitely a more time-constrained exam. But don't worry about any of that. All that to say is the more you do it, the more you learn, and the easier it becomes. So don't worry if you couldn't do it as fast as I could do it, or if other people are able to do it more than you, better than you. It's completely fine. And again, we're here to help out. So if in the future you have questions about models like this and want more practice, reach out to us. We'll be happy to help. All right. Are there any last questions before we move on to the assembly portion for tonight? All right, awesome. And if any questions come up, feel free to just reach out to us later, and we'll be happy to help out. Okay.
Okay, so now begins assemblies. Assemblies are easier, definitely easier than the part modeling section, but not as easy as the first drawing identification section. So does anyone not have the folders unzipped? So we're going to be working with problem 2, which should be the rack for today. Nobody? Everyone has it? Okay, good. Awesome. So we'll just start off by taking, is it this one? Or which one? Sorry, which Chrome window is that? Oh, no, I mean like the Chrome window.
Oh, Microsoft Edge.
Oh, you use Edge. Okay. Okay, got it. So we'll be working with this model for today, or this assembly. So with assemblies, basically, the exam will ask you to use global variables. So the parts that we use today did not go through global variables, but basically, global variables in SOLIDWORKS allow you to basically set variables for certain values, right? And this is really useful because, as you can see down here, it gives you an initial set of values to use. So A is 2.5, B is 18 degrees, right? But then in part B, they want you to change it from 2.5 to 19 and 18 to 58 degrees. So of course, you could just do everything normally and you can update the dimensions later, but it's a lot more efficient to just define these global variables first and then change them later. And the reason is because in SOLIDWORKS, equations, you just search up equations, you have this window that pops up, right? So if I wanted to define, I might as well just define it now. So A is 2.5, so we're going to just put in 2.5, click tab again, create B, B is 18. And so that evaluates. So if I wanted to use these values in a dimension, all I would have to enter in is equals and then A, or equals B. And so once I update it on this window here, then it'll automatically update throughout the entire part. So this is just really an efficient way to get through all of the different modification sections of the assemblies, and of course also the parts as well. So after we have defined these first two, we can go ahead and, do you guys want time to work through this on your own, or do you want me to just go through it? What's the consensus? Raise your hand if you want time. Okay, it's not as strong as the part modeling. Raise your hand if you don't want time. Okay, it's basically a tie. So, okay, I'll give you 5 minutes. We'll do 5 minutes. Try to finish it by yourself. Yeah. Okay, so I think the proper way is, okay, now it just appears under equations. So, do you know where to find it? I've always just used the search bar.
I normally just, when I dimension
Yeah.
I just click equals and then
Yeah.
enough greater and so on.
Okay. Okay.
But
Yeah.
you can
Mhm.
also search, because I think it's not like a toolbar, but just search for its easiest.
Yeah. Yeah. I've always just used search. Yeah.
There's a lot of shortcuts in SolidWorks that you can add, like toolbars and such. Like that view toolbar you see at the top left there, that's something I just added. I don't think it comes default with when you open up the workspace. And you can find a bunch of those. And it's really just up to, is there music coming from?
There is music coming from it. Yes. Yes.
That's really distracting. We'll just say 7:35.
Okay.
Yeah, so you can add a bunch of those toolbars, but a lot of features like that are hidden, and you have to search for them. And that's just the way it is, generally speaking, unless you want to add the toolbar for it. It's just shortcuts and stuff that you learn. I think lab 2 was saying lab 1. I think lab 2 was saying lab 1. Can you hear some voice that's not really clear? How's mine? Mine clear? I thought like when you talk, like it's not always clear anyways, or like really clear? No. We'll just smoke and see. There. Maybe like attach it like to the wall here and then pull it through. That is nice. That's so nice. Pretty cool. It's always large. Once in a while it doesn't. Yeah. I think, yeah, you want to define units for sure. When you don't define units, it'll just automatically go to whatever the standard unit is anyway. So. Also, if you didn't define it as degrees, when you do a model part 2 lines, it automatically knows you're doing degrees, so the number will just evaluate to degrees. Yeah.
Okay, I think that's basically time. Did anybody have any questions before we begin? No? No? Okay. So first thing, before working with any model in SOLIDWORKS is, of course, the unit system. So you can see that the unit system is IPS. That's correct. It's not MMGS for once. And the very first thing that we're given is that we should insert the bracket base as a base part and use this origin as the assembly origin. So I'll demonstrate this in a minute, but since for assemblies, the exam will ask you for the center of mass, which is defined with respect to the origin. So if you do not set the correct origin, you will get a very different center of mass. So to define the assembly origin, or to define the base origin as the assembly origin, we'll just go ahead and insert a component. So assembly, insert the component.
Yeah, go to downloads. This is my downloads.
Oh, so you're downloads? Okay. And so bracket base. And so when you open it, you can see that you can actually drag it and move it around. So you actually don't want this, because if you just click it when it's in some random position, it's going to define that as the origin. So to avoid this, you just click anywhere on the left side, and so you just don't move your mouse anywhere to the right, and you click yes. And so to verify that the origin is the correct position, you can just expand the part that you just inserted and go down to its origin and click its origin, so you can see it's in the little blue dot. And then you click the assembly origin, and then it's at the same position. So this is just to verify. So we have it inserted, so that's fine. The next step that we're given is to insert two wheels, and they're both tangential to the inner bottom face of the bracket and equidistant from the inner lip and back of the bracket base. And we're directed to detail D. So detail D is down here. Actually, I think detail E might be a little bit better for this. So this is a side view. You can see that it's tangent to the bottom, so the face of the wheel is tangent to the bottom of the rack, and it's equal spacing on both sides. So we'll just go ahead and insert one wheel for now. We'll insert next wheel next. So insert, and we'll insert a wheel. And as you can see, it inserts it in the correct orientation, which is nice. But of course, this may not necessarily happen. And so for this, you can just put it anywhere. And you can notice it's undefined because it has this little minus sign. So what that means is that I can just literally pick it up and drag it and move it anywhere. So it's not constrained. And in case this wheel is not oriented in the correct orientation, you want to go up to move component, and you don't want to go to rotate component. In this case, it's on free drag. But if you wanted to have more precision, you can just go to about delta by delta XYZ and then change it according to the global coordinates. But in this case, it's fine. It's in the correct orientation, so we're good. And the first thing that we should do, or the first thing that I would do, is to first define this equal spacing constraint. So this is not actually a regular mate. You find this under advanced, and it's called width. So for width, you need to specify 4 things. You need to specify 2 width selections and 2 tab selections. So width is the outer boundaries, and the tab is the middle one. So if we zoom in here on the edge, and then we look at it from the side, what we want, oops, sorry, it's inverted. What we want as the width is this little face here, and then the back face, right? Because these are the boundaries. And then as our tab, we want this inner face of the wheel, and then we want this outer face of the wheel. And so automatically mates it. As you can see, it's not inside the rack, but we'll change this soon. And for now, we can just click OK. And then we have the mate defined. So next, we want the wheel to be tangent to the bottom of the rack. The problem is that SolidWorks is not. It won't guess what you're trying to do. So for example, if I was to define a tangent mate right now with this. With the wheel face and the bottom of it, it'll just move it slightly upwards, but it's nowhere inside, right? And so to kind of force it to just cancel out of this. To kind of force it to have the correct orientation, I can just manually move it up. So I can just free drag it up, and you can see the problem is that we run into it's no longer equidistant from the sides. And so with assemblies, what you can do is press Control B, which is rebuild. You can also go up to, I believe, Edit, Rebuild, and this just basically recalculates all of the mates.
Also the top, at the very top of the stoplight sign.
Yes, that's also rebuild. And so you can see it's once again equidistant from both sides. That's good. And so now that the wheel's in approximately the right position, we can go back to mate, and we can go to tangent. And for tangent, you just specify a circular face. In this case, it's kind of circular, and then the bottom, and then it's mated. Okay, so that's one wheel. Next, we'll do the exact same for another wheel. I'll just breeze through this really quickly. Now the alternative to redoing all of the mates again is to use insert components, copy with mates. I'll show you that after I finish this, but it sometimes works and it sometimes doesn't. And the interface for that isn't necessarily intuitive. So if you're working with not that many mates, as I am here, you can just redo the mates. So just make this outer face, and it's equidistant, and we'll go ahead and mix it out, move it up a little, rebuild, go back into mate, and do the tangent mate. Okay, so those are our two wheels. As you can see, there's no cart yet, so that's the next step. We'll go back to the PDF. And we're on step 3. Two wheels are concentric to holes in the back of the cart, shown in detail E. Go down to detail E. Then we can see that the cart is here. And then if you look at the other details, you can see that it's flush. So we'll go ahead and insert the next component, cart. Again, it's in the correct orientation, but if it's not, you can go to move component, move it around. And it said that, I'll actually move this out a little. It said that this face, or sorry, no, actually this face, this little circular face here, is coincident with this hexagonal face of the wheel. So we'll go ahead and define that. Mate. This face is coincident with this face. It's a coincident mate, which is correct. And next, this circular rod is concentric with the interior. That. Okay, and we'll do the same for the other wheel. Okay, now you see that we run into a small problem. We can't actually see it. So in this case, it's helpful to use the SolidWorks Other feature, which is if you click where it's supposed to be and you can't see it, you just right click and you click select other, and it gives you a little menu to select what to actually select. So in this case, I know it's not this. I do want this though, right? So this is the interior, this interior cylindrical face. So I'll select that, and I want to mate it to the wheel. So I select the wheel, and then it mates. I believe, actually, sorry, I missed a parallel mate. Yeah, this mate. Okay, I missed this mate between the wheel and the top face. So I'll go back and define that. So it's between the top of the hexagonal face and the top of this rack. And that's a parallel mate, which is correct. Do the same for this. It's another parallel mate. Okay. So now we have our cart, we have our wheels. What's next is step 6. So here we want a distance mate. The cart needs to be a distance A away from the edge of the rack. So you can see that in detail F. And so then we'll just go back to mate. We'll select the left face of the cart. We'll select the left face of the rack. And it automatically just finds a coincident mate, which we don't want. We want to change to a distance mate. And okay, so in this dialog, you cannot actually define or relate to a global variable. You have to do it elsewhere. So I'll just enter in some random values, say like 20 inches. Click OK. And then to actually relate it to the global variable, we have to go back into mates. Click on the mate to expose the dimension. Double click on the dimension until this window shows up, and we'll say equal A. So this syntax is important. You need the equals, you need the quotes to actually relate it to the global variable, or else this dimension will not update when you update the global variable. And so when you see this blue mark, this blue color, that means it's correctly defined, and we'll click OK. And then now you can see that it has this little equation symbol, this kind of sigma symbol, which means that it's correctly related. And you can see this is definitely not 2.5 inches, which is the reason we have to rebuild. So Control B again, and now it's in the correct position. So next step. Next step is step 7. Now we need the hook. And the hook, as you can see from detail G, is an angle B offset from the alignment of the bracket. So we'll go ahead and insert the hook. And we'll put in some random position. And the first thing we want is that we'll just go ahead and make this outer cylindrical surface coincident with the inner cylindrical surface, and we'll make this hexagonal surface coincident with this bottom surface of the cart. So we're just going to go ahead and do that. Mate, select this outer cylindrical surface, select the inner cylindrical surface. Oh, and by the way, to pan, which is to move things in the same plane on the SolidWorks for the view, is Control, and then you press the middle key. Go ahead and select this top surface, this bottom one. Okay, so now if we exit mate, you can see that you can't move the hook in and out, but you can rotate it. And so to define the correct orientation, we need to use B, the global variable. And we can see that, well, it's kind of hard to see, but you can see that the hook kind of opens to the left. And then if you're looking at it from the top view, then you can see that there's an angle B. So for me, at least, it was kind of hard to see which way it's actually facing. But you can kind of see that this, from D, that's pointing towards you and not away from you. So this is the front face of the bracket where you can see the inside and the cart. So we'll go ahead and define that. And so this is the correct orientation. It is kind of hard to see from the drawings, unfortunately, but we're just going to go ahead and mate it. And so in this case, we want an angle mate, which cannot be created between a curved surface, so I can't just select this curved surface of the hook. I'll actually have to kind of do a workaround and select the hexagonal face of the hook, and I'll select the one that's aligned with the plane of the hook, so it's this face. And I'll go ahead and select, wanted me to define it according to the front face of the cart, so I'll select the front face of the cart. Why did it just turn hollow? Wait a second. Okay, so this and this, and it wants a parallel mate, but I'll force it to do an angle mate. And again, enter in some random angle value, 27 point whatever is fine. And we'll go ahead and add the relation later. So we click on the mate to expose the dimension, double click on it to expose the menu, and select and enter in equals B. And then once again, we shall see that there is a sigma symbol here, which means that it's correctly related to the global variable. And then click Control B to rebuild. And I believe that is all the mates. So with our initial set of global variables, our center of mass, which you can find again by going to Evaluate Mass Properties, this is the center of mass given. If you go to the answers, J2, 21.02, 1.39, 0.91. So we got all of these correct. And to update the global variables for part 2, it wants us to update to 19 and 58, so we'll go back to equations. We'll change A to 19, change B to 58, click OK, and then it automatically rebuilds, but if you want to manually rebuild, Control B again, and then we'll go ahead and reevaluate the center of mass, 23.64, 1.39, 26.34, 1.39, 0.91. And that's how you do assemblies. Sorry, we only had time to do one assembly, but assemblies are, relatively simple compared to part modeling. Did anyone have any questions about this assembly? Yeah.
Can you go over the width of the figure?
Yeah, sure. Yeah, that is pretty complicated mate. So for width mate, you need to go to, so normally you should see the standard tab. You need to switch to advanced. And then the width selection, you need to specify 4 faces. You need to specify the width selections, which are the outermost boundaries. And you need to specify the tab selections, which is like, a tab is like what you insert in between the width selections. And so automatically make it equidistant on both sides. You could kind of, do like 2 distance made on both sides, but the width just automatically makes everything centered. Any other questions?
I don't know if it needs a width for the CSWA. Just standard makes a lot.
Okay. But how would you do it with the standard?
I don't know. I mean, this problem is a little more complicated than CSWA.
Right, okay. Yeah, sorry.
You ever thought to dual mate or stuff like that?
That's hidden? That's in, yeah, sure. So you don't have to be inside the mate menu to use it. But for example, if I was zoomed in all the way, I wanted to select this back face. So then I would right click where it should be, and I click selection tools. Or no, it's not a selection tool. Where is it? Oh no. Do you know if you have to be inside mates?
Check if you're in mate.
Okay, I might be mates. Spoke too soon. Okay, then it appears. Sorry. So select other, and then it gives you this little menu, and it highlights the faces. So like this is the interior face, this is the back face. So if I want to select the back face, I could do that.
I think another way that might work as well is if you section viewed it, you could section view it and then select your face. And also, you could think about it like the orientation at which you want, not the orientation, my bad, the steps at which you actually want to make your mates, for example. So you'd want to do your mates that be hidden first and then assemble it together that way, rather than do like a big mates and then have to go inside to find the hidden mates.
Yeah.
So like in the problem we define the A and B word, would you be fine setting the dimensions directly, or would you have to set it as the standard that you said to set?
Sorry, could you rephrase your question?
So like,
Yeah.
for example, in the problem,
Yeah.
it does tell us like A equals 2.5
Right.
and B equals 18. Would we be fine, like, for example, on the exam, just setting those dimensions, or should we do the equals quotation mark 8?
Of course, either way is correct. But for speed, especially if you need to edit the dimensions more than once. So for example, if there's like 3 parts, you need to edit them twice. And so you may not necessarily remember which dimensions or which mates to access. And so just defining them in equations is just a lot easier. But either way is correct.
I think I can help with that.
Yeah.
I'll show you a part that I did, which shows why global dimensions actually are better to use. So if we go to this part right here. So for this part, I actually had to do a bunch of global variables. And the reason I had to do it this way was, if you look at my equations, I had 3 global variables I was using, but a lot of other dimensions were based off of those global variables, such as certain dimensions were like a times 5, a times 3, or a times 2/3. And what that meant is, if I were to update each one individually, I'd have to go back and recalculate all of them, rather than just being able to change A, B, and C values up here, and that automatically fixing the entire, changing the entire.
All the other dimensions.
Correct, yeah. So if I go to like B, which is like part B of the equation, it changes all these values, and then these stay the same, but it updates the entire model. If you look at the model behind here, it's changing as I change from A, B, and C, because it is changing those exact A, B, and C, which is all linked to the rest of the dimensions. So as Abe said, for 1 or 2 of them, it's fine if you don't exactly use global variable. You don't need to do the exam, but it will make your life a little bit easier, and chances of making a mistake are less, because everything is linked to one source, so you can go back and reference that one. You can exit out here if you want. No, those are really good questions. Keep them coming. Any other questions? Yeah.
For like part 4,
Yeah.
In general, you want like the rim to be like outer, like inner part of it.
If there's a chamf, yeah, I guess, but if they're on the same plane and you don't anticipate it to be changed, then anything would be fine. You can select the face, the chamfered rim, you could select the outer, because I don't believe on the CSWA they'll ask you to modify the parts given. So you should assume that just the parts given are the final product. Like they're not going to change it. The only thing you're going to change is the mates and how they're oriented. So as long as it's visibly in the same plane, then you can use anything on that plane to define. Does that answer your question?
Well, I mean, is there like a good principle for deciding like one or the other? Because like in like detail, you can't really tell whether it's like which part of the card is like principal.
Sorry, you said
Like,
detail.
you can't tell whether the hexagonal part would
Yeah.
go, like stuck in or all the way through the chamfer or not.
Right. Okay. Well, if it was like stuck further in, then there would be interference between the chamfer and the horizontal. So I mean, yeah. I mean, it's a little bit of assumption there. Yeah. That's a good question.
Generally speaking, it's okay to make certain assumptions if they seem to be pretty obvious. Like certain things, like you can assume if it looks like it's the same plane, it's coincident. That's a fair assumption, unless something explicitly says otherwise. Like, remember when I assumed in the part modeling that both the radiuses would be the same because they look like they're the same? It's one of those things where try it out, and usually it'd work itself out.
Okay. We switch back to the slides.
So one thing I want to point out, though, is when you're actually modeling for the CSWA exam, they're not going to give you a step-by-step of how to do it.
No.
That was more so just for the practice part of it. What they're going to do is they'll give you the assembly, and then they'll give you a bunch of mates. They'll tell you, they'll point to 2 spots, and it'll be like, this is a mate that you use in these 2 spots. Like, here's a parallel mate, use a coincident here. And it's your job to figure out exactly how, I guess, looking at it, like orient it properly and add those mates as you need. And when you do the CSWA sample exam, you'll notice it because it'll take you through those and give you practice with that. In any case, do you have any other questions regarding any of the parts we've gone over so far? Awesome. Okay, well, moving on to which one here. Okay, well that basically concludes what we've done so far for today, and that's what we have. You guys have the extra parts if you want to go over them, practice on your own, and get back to us. If you feel like when you model the part and you get the incorrect mass but you're not sure why, or if maybe you think you did everything correctly and it's just still wrong, let us know. It's possible the answers might be wrong, and we can double check that for you. So if the masses don't line up and you're confident on what you did, that's okay. Reach out to us. We'll be happy to help you out. What we require, so let me go over really quickly what the how to get the sample exam, how to get the certification test. If you go to this website right here, which is solidworkslp.org, it's also shown on that screen. If you go here, this is our website, and if you go to certifications tab, scroll down, this explains how to get the voucher. What you need to do is take this exam, which is linked here. It's a PDF that basically goes over how to download the the proctoring software, what the exam is, and how to take it. So we showed you those parts in the images. Let's see. Assemblies will look like this, and it'll point to certain parts. Yeah, and then it's key. So you just take this practice exam. It looks complicated, but trust me, once you actually get into it, it'll be simpler than it looks. Anyway, after you do the exam, it'll give you a score telling you how well you did on the exam. And you click this link, and you show us a screenshot of what the score is and what exam that you're trying to, well, obviously this is for CSWA, but if you're interested, you mark that down. Submit it, we'll see it, and then if you have a passing score, we will email you a voucher. But the thing is, we can't email vouchers at the moment. We can only send tests to accounts associated with your UCLA emails. So when you fill out this form, make sure you put in your UCLA email, which is said right here at the top. Because if you don't, we can't really send you an exam. The exam will then be in your SolidWorks account, meaning when you create your Tangex software, which is at the top here, you have to make an account with the proctoring software right here. Yeah, you have to make an account. make sure you make it with UCLA email, and then we'll be able to send it to you that way. It'll be automatically in your account, and you have to take the test within 30 days of receiving it. If you're not confident and you don't want to take the test yet, that's completely okay. You can wait. We're going to host more of these workshops in the coming winter and spring quarters. You can attend more of them, get more practice, reach out to us if you have questions, and when you're ready, you can try and take the exam. However, you can't take the exam back to back. So if you fail it one time, you have to wait, I believe it's like 2 weeks or 4 weeks, a certain amount of time before you're actually able to take it again. But usually if you pass a sample exam and you do well and you're confident, you should be completely fine. Don't stress about it. Are there any questions about anything we went over today regarding what we do, how to take the exam? Yeah. You get one exam. I mean, if you fail it, then we'll talk and we'll get you a different exam, but you have to wait a time period. That waiting time period isn't even our rule. That's just the SALT systems that say you can't take an exam, same exam in the same period of time. Yeah. Yeah, we'll send out the slides to the emails that you filled out when you signed in. If you didn't sign in, let me pull that up real quick. Please sign in, because if you didn't, you're not going to get the slides. We'll email these directly to you guys, and then yeah, you'll have them. And if you have any questions, message us on Slack. We'll be happy to answer them. You can reply to our emails. You can email us. Yeah.
Can you just put the URL before the slide again?
Yeah. Here we go. Yeah.
When can you like take feedback? Like, can I just like theoretically can I just take it like right now?
Yes.
You could take it in the next 30 minutes. We need some time to like get the form. Like you need actually like 2 hours, because you need to take the sample exam first, and then submit that to us, and then we'll get it. Look at your score. We'll send you a voucher. Then yeah, like you could do it tonight. It is possible if you want to take the CSWA tonight. It's very doable. Yeah. Any other questions? Yeah.
I guess not related to CSWA, but like the CSWP, if we're interested in going to that also as well. Is that just something, do you guys also have workshops for that? Or?
It's more, we don't have planned workshops for CSWP. If you're interested, talk with us. We'll be happy to help you out. Both of us have the CSWP, and so we'd be happy to work with you to get that. The reason we don't host workshops is, unless we have like a large interest for it, a lot of people are content with getting the CSWA and don't want to go farther. And it's especially fair for the CSWP because that is a lengthier exam. There's 3 parts to it, and it's a lot more knowledge you have to learn. You have to be a lot more skilled in SolidWorks. It's a lot, for that exam, it's not just being able to model, it's being able to model efficiently. When you saw like how I thought about the process of it, those parts I showed can be modeled in many different ways, and some will take longer than others. For the CSWP, you need to know how to model the part, because if you model it the wrong way, there's a chance you're not going to be able to do it in the amount of time that it gives you. So it's just a lot more practice. But we can help you with that, and we can get you going on that path. And we can also give you exams for that too. There's also other specialty exams. You can search up just like SolidWorks. And then they have the, if you go to like SolidWorks website, they'll list all of their exams. Let's see here. All right, I guess it's not here, but. Oh, one thing I want to make clear is what you see here in the About the Exam portion, make sure you know how to do all of these things. This is basically the rubric. Not the rubric, but like the guidelines. Like they're going to test you. Like anything on this is fair game. If it's not here, you don't need to know it. So it's basically all your sketch entities and all your feature tools you need to know. You don't need to know advanced mate. So that with mate I talked about before, you don't need to know that, but you should know all of your standard mates. Okay, like a 14-day period between retaking the exam. In any case, there are other exams that you can take. Yeah, here. Okay. So I mentioned before there's the CSWA. Then there's like the additive manufacturing exam. So CSWA mechanical design, there's mold making, drawing tools, surfacing, mechanical design, electrical. There's a lot of these exams, and we can also provide, if you look into one and see the one that you want to take, reach out to us. We can probably get you an exam voucher for that. But we don't host workshops for those, but we can still help you out if in any way we can. All right, any other questions? All right, everyone should be on Slack right now. We'll send out the slides to your emails. We'll also send out a feedback form. If you guys could give us feedback on how we did, anything that can be improved, please let us know. It'd be very helpful, especially for future workshops. And if you're interested in attending future workshops, let us know there too. Anything else, reach out to us. We have our email, our Slacks. And yeah, we hope you had a great time. and have a wonderful rest of your night. Good luck on finals next week, and hope you have a good Thanksgiving break.
Yes.
We should stop the recording. Also, if you want to talk to us afterwards, feel free to just come up to us and talk to us.